2, 1. Hey guys, how you doing? It's Coach Scott. Hey, we're getting ready to go into Unit 4. Unit 4, which is the unit on ionic bonding, right? And ionic compounds. So now the first little unit, we're going to go ahead and review the periodic table. We just covered it, but let's make sure we know what we need to know about it, right? So, first of all, let's get our definitions right. The periodic table is periodic because of the trends that are seen in the elements, right? Some of these trends can be seen in how the atoms, we covered it in the last unit, right? We talked about what? Atomic size. We talked about ionization energy, right? Atomic size, how big the atom is, right? Ionization energy, the amount of energy required to remove one electron. Electronegativity, the attraction due to Zeph of a atom towards stealing another electron from another atom. And then, of course, the metallic character or the willingness to give up an electron by a atom. So, would you predict that elements for the same group would have similar physical and chemical properties? And we talked about that last unit, right? And they do, right? They do. And now we're going to review why. So, our periodic table is divided into three large classifications of elements, right? Our first one, all right, the elements in blue, all right, what are they? Well, we'll talk about it. And the ones in pink, all right, and how about the ones in yellow? So, if you recall, the ones that are blue are metallic, or they're metals, right? They give up electrons. The ones in pink are what we call metalloids. There's like 7 of those. Arguments on that last one, astatine. They have properties of both metals and nonmetals. And of course, the ones in yellow, those are what we call what? Non-metals. So, what's the relation between metallic character and Zeph, or the effective nuclear charge? Think about it. Are they directly or inversely related? Can I say that element A is more metallic than element B, even if an element B is a non-metal? Right. We've answered that. Yes, we can compare about the metallicity of an element depending on what part of the table it's in. All right, is it in this area where it's mostly non-metallic, or more down here, which is more metallic? We've answered those questions. So let's have a little check here before we move on. In the periodic table, the elements are arranged in what? Give you a second, take a break. Of course, that would be B, right? The order of increasing atomic number. Elements exhibit similar physical and chemical properties. Let's think about that. Well, pause. And of course, the answer to that is elements in the same group exhibit similar physical and chemical properties. Which pair of elements would you expect to exhibit the greatest similarity in their physical and chemical properties? Well, we've got lithium and sodium. They're both in group 1. Cesium's group 1. I'm going by memory. I don't have a periodic table in front of me. Barium, I think that's group 2. Calcium and silicon. I know calcium's in group 2. Silicon's in group 16, I think. 16, not group 14. And then germanium and gallium, yeah, they're like in group 13 and group 14. So lithium and sodium are in the same group, and of course that would be A. Which of the following is a non-metal? Well, you got W, which is tungsten, SR, which is strontium, and OS is osmium. I think it's in the transition, the D block. And then, of course, sulfur Sulfur, I believe, is below oxygen. So, of course, that would be D, sulfur. Potassium, group 1, I think. That's a metal. And chlorine would be a non-metal, so that would be A. Okay, there's a review of the periodic table. Now, let's talk about what we call valence electron. Valence electrons and what we call the octet rule. So, we know that atoms, we know now that atoms want to be stable. And what makes them stable is when they get a complete outer shell of electrons. And in the periodic table, the complete outer shell is what group? Of course, group 18, the noble gases. So, a full outer shell will have 2 electrons in the S subshell, okay, and 6 electrons in the P subshell. So each of those 3 orbitals will have 2 electrons, and that one S orbital will also have 2 electrons. 6 plus 2 would be 8, right? The configuration would be S2P6. So here's the octet rule. Atoms tend towards having a total of 8 electrons for stability. So 8 valence electrons will make an octet. So which elements on the periodic table have a complete outer shell? We answered that, of course, the noble gases. Now, what do we know about the noble gases as far as reactivity? Think a second. They don't react. So, valence electrons are the electrons in the highest occupied energy level of an element's atoms. So, these are the electrons that will determine the chemical properties of that element. Why? Because these are the ones that you're going to either take or borrow or share or whatever, the electrons in that outer shell. Now, to find the valence number of electrons, or to get the number of valence electrons in an atom, okay, of that element, all right, those are pretty much in the S&P blocks of what we're going to worry about. All we have to do is look at the group number. So atoms in group 3 will have 3 valence electrons. Now with the new numbering system, if you're in group 17, drop the 1 and you'll have 7 valence electrons. If you're in group 13, drop the 1 and you'll have 3 valence electrons, like aluminum. Wow. So how many valence electrons does aluminum have? Just told you. 3. Let's see. So how many valence electrons does potassium have? Potassium's in group 1. There's 19 total electrons, but only 1 valence electrons in the outer surface. So here we go with the periodic table. This is what we're talking about. So you got your periodic table, and you go right here in group 1. All of these have 1 valence electrons. This is group 2, right? So all of these will have 2 valence electrons. Don't really look at the transition metals because they're different, because they're D block. So they can have anywhere from 1 to 4 valence electrons. All right, if I look at group 13 rather, drop the 1, we've got 3 valence electrons. And like I said, 14, drop the 1, 4 valence electrons. 15, drop the 1. Do I need to go on? I think we get what we're doing. Now, there is an exception. Helium, though we call it a noble gas, because it is complete with 2 electrons in the outer level, in that first energy level, is complete, but it only has 2 valence electrons. So how many valence electrons does barium have? Let's find barium. Barium is BA. Oh, it's in group 2, so of course it would have what? B2. Arsenic has 6 valence electrons. Well, let's go back to the periodic table. We'll find arsenic number 6. Arsenic number 6 right there. Well, we can see that it is in group 15, so that would be what? 5 valence electrons. So that statement is false. So, okay, guys, here we go. We have now reviewed the periodic table. We've studied the periodic table. Hopefully, we've grown to appreciate the periodic table. Okay, and let's go ahead. I'm gonna blow me up just a little bit. And what have we done here? Okay, we have went over what an ion, or we went over valence electrons. Some of y'all may remember this from other classes, right? Valence electrons are just the what? They're just the electrons in the outer surface. So valence electrons, we can use the periodic table to determine what the valence electrons, at least in group 1 and 2, group 13, 14, 15, 16, 17, and 18. And we'll get into the D blocks, the F blocks, at some other time later on. Okay, guys, so this is Coach Scott saying have a wonderful day, the rest of your weekend, and we'll have a good time tomorrow. Thank you. Have a good one. Deuces. Bye.